Oh boy, here we are. Welcome back to another week of hacking in Haskell. We're making a game. It's so far a text UI driven game based on an old classic from as far back as I think in the 1970s called, well, we're calling it Lambda Trek, but it's based off of Star Trek or Super Trek or whatever you want to call it. And yeah, that's what we're going to be building this week, as we have been for a few weeks now. So, let's get started. And if this is your first time tuning in, welcome. Nice to meet you. You can feel free to stop me anytime to ask any questions or anything like that, because I'm always happy to help, and we're here to learn mainly. Yeah, so let's go over to the project directory and get our file watcher going and building the project, and I'll show you where we're at so far. The fast option and file watch. Bam. There we go. We'll bring up another terminal because it's a terminal-based app. Make it a little bigger. I need my Linux one. Sweet old Linux. Okay. Here we are. And this is what the project looks like so far. Lambda Trek. Alright, nothing schmancy yet, but we're getting there. So this is our... Right now we're just working on quadrants. We haven't done the star map or anything like that yet. And we just started this little panel on the right hand side that's going to be our ship status panel. So how much energy we have, our shields, our torpedoes, things like that. And down here we have a dialogue system, and that's for the different crew members to give us messages about things that are happening in the game. We have our command handling. Alright, so there's our helmsman telling us, our helmsperson telling us that we would go directly in the star if we tried to move to 1010. Here we have a little enemy ship. And that's what this little arrow is. The S is our ship. And this little star is the star. Hopefully that's all pretty straightforward. Okie dokie. So today, I think what we're going to get working on is phasers. I think that's what we should do. Now, in classic Super Trek, Star Trek, whatever, your phaser command had like two modes to it. All right, you would have an automatic mode and a manual mode. And the default mode to choose, I think, was automatic, if I remember correctly. So you would just say like phaser, and then you would tell it how much phaser energy to use. And then it would automatically fire on all the enemy ships in the quadrant. And in the automatic one, it would kind of just try to evenly divide up how much energy it uses on each ship from your command, as much as possible. And in the manual one, the manual mode, it would fire on all the ships, but it would cycle through the ships one by one, and you can tell it how much energy for each ship to use. Alright, so the enemies had a certain amount of health to them, like damage they could take, and it would be somewhat random when the sector is generated. And then, yeah, and then your goal is to destroy them. So I want to make this a little bit more tactical, in that I would like there to be a range on the phasers. And so that we can we'd have to maneuver around the sector here a little bit in order to get to the different Klingon ships, or the different ships. I'm not going to call them Klingons, but we'll figure out a different name than that'll fit into our little universe here. But the enemy ships. Green juice. Stay healthy, friends. Okay. So that's what we're going to do. We're going to do basic phaser firing. We're not going to get... Yeah, I think we're going to do distance. So we're going to max out the distance on it. You can specify how much energy to use in your shot. And then we're going to target all of the enemies we can find in the sector that are within our range. And that's what we'll do. All right, we haven't implemented shields or anything like that, so we'll worry about shields later. So that's what we'll do. All right. Let us get to the Lambda Trek ship in the simulation. Okay, so there's our ship energy, position X and Y. No. Well, let's do the command parsing first. That's what we need to do. Okay, command parse. There's our parser and our command module. That one. Okay, so our command's going to be phaser, fire phasers. Okay, in order to fire the phasers, we're going to take int, which is going to be the energy amount. Maybe a word. So a positive integer. But since we're using a parser for the command, I think we can safely use just int here. And we're not going to be we don't construct these commands like manually through our program. These are parsed from the users. So. The parser can, of course, guarantee that the int will be positive. And then, yeah, we'll do multiple modes, but we'll focus on automatic first. So we'll have a data structure for that. Phaser mode. We'll call phaser automatic. We'll derive our usual classes for that, equal to show. So an integer and a phaser mode. And we'll do a maybe phaser mode. And of course we need ord as well, so that, yeah. Okay, so already we're getting some type errors there. We added a new command that's not being handled, which is good. So we're gonna go pop over to simulation. And we'll just add this here, where we are going, just like jump move, we'll just put in a it'll just return game state for now, just so it compiles about that warning. Super duper. Okay, now we'll go over to the parser. Let's see, we'll parse engine move, jump move. To parse fire phasers. Okay, so first we're going to match the string. What should we make our string? Phasers? Sounds good. We'll skip some spaces. Then we'll have our amount. We're going to parse a number. Do I have a number parser already? Hopefully I probably do. Digit. And then we skip some spaces. And then we're going to need a parser for our phaser fire mode. And go to the end of line for that, or file and return. Fire phasers. Mount fire mode. Oh, it's just digit, sorry. Okie dokie. Parse phaser fire mode. So we have two string options. Or it could be an empty. Oh, that's going to be interesting. Do we have anything in read P for trying a parser and returning maybe? That's what I need to find out. Text. Parser combinators.read P. Probably not. It's a fairly primitive parser library. Okay. Symmetric choice. Optional P. Parses consumes P but returns unit. Well, that's useless. Skip many, set by, end by, chain, many till. Okay, well that's not very super awesome. Let's see. We could... What would phaser fire mode? I was thinking it would be like string, auto, and then what was that plus 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 plus? Manual. Yeah. Yeah, I don't know. Whereas then we would have like phasers. Phasers 23. And I want to be able to be like phasers 23 just means auto. Phasers 23 auto. Or we get phasers 23 manual. So like having to parse this, I think it's enough. We only have 2 cases, so it's really just enough to have the one specified or not. So I think even in our command definition, this shouldn't be maybe. It should just be phaser mode. We'll add phaser manual as well. Okay. There we go. Option, I think, will be good in this case. I don't think we even need to define this. Go option. And we can give our phaser automatic. Or we give it a parser, and that'll be string manual. Okay, and of course we need to import that. No, that should be there. What do I need here? Oh, right, okay. They have to be the same A. So, we will... Yeah, parse phaser, manual phaser mode. Parse phaser manual. Ah, that'll be it. Phaser manual. Parse phaser manual is what we want there. So if this one fails, that's fine. We'll get... but this one's not going to return command. This is going to be a repeat for just phaser mode. We could just do string manual, ignoring that, and return pure phaser manual. Ooh, is it the wrong one? I did want the functor one. Okay, so I gotta import data.functor. That's one. I don't think we've used that one very often. on the stream. Neat. Okay, so all this parser does is it just matches the string manual, consuming that. And assuming this passes, it just then it drops that result and just returns phaser manual. Right, so if we run this down in fire mode with option here, if this fails to match, then it'll just return phaser automatic. So hopefully we can test out this parser. It's read P2S. Read P2S takes a parser and a string. Okay, cool. So we get it right with our phasers 23 phasers automatic. If we do manual, we just get phaser manual. If we mistype something, we just get nothing. That's sweet. Oh yeah. Okay, so let's create a commit for this. Bang, staged it up. Fire phasers command. Okie doke. So if we go into simulation now, we can begin to start implementing a handler for this command. Okay. And this will be where the meat of what we're going to be working on, I think, is going to be happening on tonight. Handle fire phasers. And we'll bring in our parameters. Amount, fire mode. We'll have to give it the game state. Okay, so we get the game state, we got an int, we got a fire mode, phaser fire mode, and we have to return a game state. Let's leave that undefined for a moment, just get our imports going. No, phaser fire mode isn't the one. Phaser mode. Sweet. Okay, here we go. I like it. Loving it. All right, handling firing the phasers. First, we're going to need to know what enemy ships in the enemy ships array are within our firing range. So we are going to have to leave this undefined for a moment, or just ignore our arguments, except for game state. Just turn G for now, because we're going to need some data. Let's go over to the ship. Got an energy amount, which we can draw from when we fire the phasers, but I just want to add the phaser range. Okay. Maximum distance we can target enemies. And we're probably going to have to update a couple of places. State. That's right. That's the one I was looking for. And let's initialize it with, like, 6. Okay, 6 is going to be like our phaser range for finding ships. And what does 6 mean? Is it radius or like what? And I think to keep things simple in this grid-based world that we are simulating, we should make it just the radius based on the Manhattan distance out from the ship, basically. So what is the Manhattan distance? Let me bring up my pen. I'll draw it for you. Or we could just do it in a box. That might be easier. Calculations wise. Choices to make. Okay, so we have a grid. That is our universe. How? This is my awesome drawing. Alright, and the Manhattan distance between 2 points on here to here and here, right, is how far between them by only making orthogonal direction choices. And it turns out, like, no matter which way you decide to go, it's the same number between them. Now, the formula, if you don't know, is x1 minus x2, taking the absolute value of that, and adding it to the absolute value of y1 minus y2. Spimple. Super smimple. And if we plot all of that out, we get basically like a diagonal kind of like diamond box around our central point. So it's not like quite a circle, but like calculating the circle is not that much harder, but it's hard enough that I think visually it would just be like kind of annoying to try to figure out like where in your targeting distance you can reach. The other choice we could do, I was just thinking of, is we could just do it by like a box around. Our ship. Alright, so if we had our ship here, and we said like our radius is 2, alright, then we can go, okay, 1, 2, so like these boxes here. And up here. So everything the ping passes through would be considered in range. And I think I kind of like that one better. So when you're playing the game, go to my awesome art, you can kind of like pick out the range around your ship fairly easily if it's just a box. You say, oh, okay, well, I clearly can't hit this ship yet, so I need to move a little closer and get wrap my box around that ship so that I can target it. So I think that's what we'll do. We'll go for a box. See how that goes. Okie dokie, so that's the radius of the ship, the maximum distance to the targets we can find. Okay, back to the code. Back to the simulation, and... Okay, so now from the game state, we need to be able to pull out the enemy ships. And... yeah, in both cases, both cases of the phaser mode, we're gonna need the list of enemy ships that we can target within our box. We should focus on getting that. Let's go. Let's have enemies. Okay. We are going to have to calculate our box. Give it a list of enemies. And then it should filter those enemies that are within our box. So you can probably give that as like the top left of our box, I guess, and like an offset. So you'll probably give it right about like the top corner here, and like how wide and tall we are as inputs. And then it can just figure out which enemy ships are in there. Okay, okay. Smoke it. So, our range top left. Range top. What are we gonna go? Range box, start, range corner. And then we'll have like range box offset. And then we can get enemies. This will be a filter of enemy in range. Which is going to take the range box corner, range box offset, and it'll get the enemy and Bob's your uncle. So this is going to need to take a list from our game state. So I'm just going to expand G here just to be game state. And we need the sector and enemies. Yeah, no enemy range is defined yet. Let's see the error. No, I just meant... Oh, I didn't fix the lenses for those, did I? Game state sector. Ooh, I should probably rename this. Enemies in range. Apparently not a problem. Sector. Okay, we called it sector enemy ships. Enemy shippies. Enemy ships. Okay, cool. That's what we want, and we gotta get enemy in range sorted out. So that's going to be a tuple of int, and a enemy, and then a bool. Top left, offset, enemy. And since the enemy here is on the left-hand side of the final arrow, I'm going to use record wildcards here. Just pull out his fields. Enemy. Why don't I have that in scope? There we go. Language, record, wild cards. There we go. Sick. Okay, so we just got to fill in this hole now. So we know what the enemy X and Y is, and to be inside the box, the enemy's X has to be greater than the top left X. Okay, so the enemy X. Enemy position X has to be greater than, or we'll make it greater than or equal to top left X, and enemy position X is let's see, top left X plus offset X. is greater than or equal to top left x. And gonna be, then we'll do the y-axis. Any position y greater than or equal to top left y, and top left y plus offset y is greater than or equal to enemy that's right, enemy position x, enemy position y. Okay. So then we have a few more holes we still got to fill in here, of course. Our range box corner. It's going to be based off of the player's ship. So we'll get, we'll bring in ship X, ship Y. And this becomes ship X. So we want the top left from our current position, as long as it's within bounds. So we're going to want a min. It's going to be a tuple. The first element of the tuple is going to be a min of 0. And let's see, top, our current position minus, so the ship X minus the ship range. Call ship R. And the same with this one as well. Just for ship Y minus ship R. Okay, and the offset is going to be also a tuple, the same thing, except this time the max of the sector size. I think it's 15. This will be ship X plus the ship R. That makes sense. Alright, and then game state, the ship X we can get from game state. Game state ship. Ship position X. Yeah, that should be it. Let's see, what's the problem here? Maybe a little breathing room. Oh, what did I call it in the state? Mirror. Just game state ship. Yeah, that's fine. Oh, I do have... Oh. Yeah, let's just position X. So we need shift dot position X. There we go. And then ship Y is the same. Phaser range. I don't like have to use all these lenses to pull these out. Seems kind of annoying. Let's go with it for now and finish this, and then we'll refactor that down. We have one more hole left. Oh, I got another type error here. Let's go fix that quickly. Let's just do this. Game state. Okay. So now we have enemies in range, and we have everything we need to know about our ship. So now we can case match on our phaser mode. Let's bring that into scope. Alright, so we have firing mode automatic, I think we called it, or what are they? Phaser automatic. Makes sense. Phaser automatic. And phaser manual. Okay, cool. So, phaser manual is going to be an interesting one to handle, because it's going to require us to come back to ask for more input from the user in order to keep processing this state. Interesting. So I don't know how to handle that actually right here, because we can only return a game state, and this game state just gets pushed back into Brick, and Brick will update its current state of everything. Whereas we need to break this down into like a multi-step thing if we're going to do manual firing mode. So I think I'm getting some ideas about how we can handle that by having extra state variables in the game state where we can tell like the main command loop that like there's more to this, put that before you can move on. Put the game into a different mode, but for now I'm just going to leave that as game state. I just do nothing. And phaser automatic, we can handle here in one go. All right, we just have to update the enemies in range that we have. And how are we going to do that? Because right now that's as a list. And filter is filtering down that list. And presumably we'll only want to replace like if we want to like update these enemies using that we get enemies in range and calculate the new value for those based on our firing mode here. We could certainly do that, but then we need to just replace part of the enemies list in the game state because there might be other enemies we didn't target this on this turn here. I don't know. There might be a way to do that with equality checks, probably. Not the most efficient, but I don't expect these lists to be very big, so it probably doesn't really matter. Something like a merge or something like that. Although the enemies we calculate now will have different values, so equality wouldn't work anymore. We need some way to identify. The list isn't a good enough structure for us to move ahead here. Yeah, that's not going to work. We'll leave that as game state for the moment. And we're going to go work on fixing that up. It's in sector. Okay. So what we really need is indices. And then we can say that, okay, we can get the list of enemies with their indices when we go to filter the enemies in range. And then we can do an update in place for the enemy list. So we're going to need vector to do that. We could do it with array, which is built in. And I think array would have that as well. Yeah, so we can get, with the associations, we can get the elements with their index as a tuple. And then we get array updates. And then XMAP allows transformations on array indices and maybe thought of providing a function composition right with the mapping the original array embodies. Oh yeah, that's not what we want. I think this will be the function that we could use, yeah. So then this would take our input array from the current state, our list of updated targets that we've hit and we've done changes to, and then we get back the array with just those elements changed, I think, right? Construction array identical to the first argument, except that it has been updated by the associations in the right. Yeah. Okay. So we'd have to figure out how to, yeah, we'd have to get the assocs filter on that, and then we can use this to do the update. Okay, so let's change that to an array, and get on this. Okay. Data array, but not data.array. Immutable non-strict arrays. Okay, so since most functions involve the class X, this module from data.array, so that module you don't know with data array and data. Okay. We import data.array, and we're good. We're off the races. Git-wise, we can, before we embark on this array journey, let's keep our change small here. Make a small commit for this. Add fire phaser handling. Doesn't do anything until we can fix the enemies into an array. Okie doke. So now we can do this and a small change. Yeah. This will be an array of integer indices with enemies in it. And then we gotta go to sector 32. And we need an array with list array. This has to be a tuple. And if I remember this library right, this is the index bounds. So like 0 up to and including the size. Okay, so this should be, let's see, yeah, simulation line 40. All right, so our collides with enemies needs to be updated because it's not a list anymore. Should be pretty straightforward to do, though. We don't need the indexes on this, so we can actually just convert the array, the enemies to a list. don't think we'll get any. Hopefully, we won't get any clashes. Actually, I'll just be careful with this one. Qualified. And we'll do array. To list. Elements. That's fine. And what's the next one? So this is our handle fire phasers bit. I need some updated. Okie doke. So yeah, so we said we had to get the enemy ships. And we want to convert that to the Assoaks. And filter that. And so filter is going to have to change. There, because we're going to get an integer index. We're going to ignore. Okay, that's going to fix that. Okay. That's that. When applied, this change will store sector enemies in an array, so we can index into it and update particular enemies. Super duper. Okay, so now with phaser automatic, now we can do some stuff here. So enemies in range is now a list of those indices and such. So we need an equation for splitting up the amount that we're given of energy. And we need to update the player ship to remove that amount of energy. So let's go, leave fire mode alone there. We'll go add amount. Let's call it energy amount. There we go. Okay, so we're going to need to divide the amount by the number of enemies in range, and we'll try to do this max amount. And in original Super Trek, there's a little bit of variance to the equation of like how much damage the enemy actually ends up taking. But we'll do this max for now, and then we'll refine that formula as we go along. So just to get it working. Okay, so how do we want to do this? We need to use enemies in range and calculate the new updates, the updates that we want to do that we're going to put back into the array. So we're going to need enemies, damaged enemies. Okay. Right. So once we have damaged enemies, what can we do? We also need to update the ship. Well, we need to subtract the energy from the ship. Alright, so we'll have... I almost want to do this in like a state monad. I might make this a lot cleaner. So, let's see, how would I do this? Game, state... Game, state, ship. We're going to do a... over. Yeah, and over that we're going to subtract the energy from the ship. Well, that's not the name of it, is it? It's squiggly percent. No, percent squiggly. That's over. Yeah. Okay, then we got a function ship to ship. So I'll call it subtract energy as by some amount. Now subtract energy is going to have, we're going to calculate the total damage we actually did because there might be some remainder. Alright, so damaged enemies is going to do something with enemies in range, divvying up power that's used for each hit and calculating some remainder. So I think we need like some kind of structure we can fold over the enemies in range that will keep track of that stuff that we can return. I'm going to call it damage report. And I'm going to subtract from the energy, I'm going to subtract damage report, energy used. Okay. And that's what that will look like. We ought to define some of these things first, but I think that would work. So, let's see. Need a damage report. That's going to have enemies. Damaged enemies. That's going to be just as before. It's going to be our list of couples of int enemy that we're going to use to update the array. Damage report. Damage. We can even keep the calculation of the damage dealt, but energy remaining. Well, we need energy used. That should be sufficient. And then we got to make the fields for that. Micro, th. We need functional dependencies, multi-param type classes. Here. There you go. Okay. Oh, I need template Haskell, of course. Okay, and that's going to complain to that because the template Haskell splice, I think. So we could put that in a module. Let's call it combat. Lambda trick simulation combat. Pull in you. And we'll pull in you. And you. And we'll import micro.th. And a sibling module. Track simulation. And then we need to import that here. Here. Simulation. Combat. Bring it in the combat. Hopefully no module cycles. Oh, sorry, I need also flexible instances. What did I do? What did I do? I pressed something. Oh, some hotkeys for a different program. There we go. Flexible instances. Bam. Okay, so now we're back to a good state here. Okay, cool. So we just need to define subtract energy, which I'm going to put in the ship module. Right, and that's going to be an amount, and then ship to ship. And we'll use our handy dandy update syntax. Where energy is no, we use update, and this will be subtract. Something like that. It's kind of ugly, but whatever. It's fine. What did I schmick or something? Yeah. Billy me. I need to import lemons.micro, of course, for those. So I need to put glorified. Okay, and this type error is... Oh, it doesn't know what damage report is yet. Okay, so now we need to fill in that hole. And we still need to figure out what to do, and then we need to replace the... We need to do the array update for the enemy ships. Which means, I think, when they're dead, we're gonna have, or like when they're destroyed, we're gonna have to yeah, we're gonna have like a flag on them for destroyed or something. Okay, so our damage report is gonna be like a fold over the enemies in range. We'll create an init damage report, and it'll be over enemies in range. Okay, so let's go over to combat. We're going to create an int damage report. I think maybe I can put it... like this. Damage report. The damage report with No enemies yet. And no energy used yet. Yeah, that should be fine. Nope. Well, I'm gonna have to qualify that with this stuff pulled out prime. Okay. So then our function here is gonna be our combat calculation function. So we could define this in the combat module, like handle combat. I think actually, yeah. Let's go to combat. Did you hear him? Damage report, energy, total. Yeah, we'll init that with it. So I want to initialize the damage report with the energy that we were, the player input as how much to use. And then we'll have an automatic combat report. This will take our accumulating fate here, our damage report. It's going to take an enemy. And it's going to return a damage report. Although automatic combat report probably isn't phaser. An automatic phaser fire report. Yeah. And so each of the enemies we know we're going to be firing on in the automatic case, we're going to try our best to evenly split the damage. So we can't calculate this as we fold over each enemy, but we can calculate it at the start right away. So energy used should be the total that was used, because we might have a remainder that we don't use and we split over. Then we need a variable for the energy dispersed to each enemy. I think that's what our input should be for our damage report here. In which case we would know already how much energy damage to apply to each enemy. Yeah. So really we just want to apply the damage to each enemy. Yeah, so it's more like a map, I guess, than a fold. Because we could calculate all that stuff up front. So maybe we don't need this whole damage report thing, but I like the idea of having a combat module. Let's see here. So this formula, this damage report here, stuff might go out, I'm thinking. I'm gonna put that as a whole, back as a whole here. Because if we do damage amount, that's the amount to apply to each enemy in this phase, in this turn, is the division throwing away the remainder of the number of enemies in range and the amount. Right? Then, damaged enemies. There is now a map function over enemies in range. And some function that's going to take the damage amount. And this hole here now becomes damage amount times the number of enemies that we damaged. And we just have to use damaged enemies to update the game state. And I think this will wrap that up. So, good timing, because we're getting close to the end, my friends. Getting close. What was it, evening? Okay. So, let us focus on damaging the enemy. I don't know if we're even going to use this module at all now. Maybe later in a refactor or something. We'll see. Anywho, for now, damage enemy could be in the enemy module. Alright, some integer amount. Enemy to enemy. We're going to want to import lens.micro. Enemy, it's not really health. It's kind of health. Just call them hit points. Yes. So this is all very, very simple right now. We're ignoring a lot of like logic rules and stuff with the game, and we haven't put like a dead flag on it or anything yet, but we can start fleshing that out once we get this code here. Plus. Okay. So now we can subtract energy from, so we can deal damage to damage an enemy by some amount. Okay, so now we just have to add damage, or do the update on the enemies array in the game state, and we're good to go. So I'll do, can I do it like this maybe? Game state sector dot enemy ships, and we're going to need that in scope, so we'll use over again. And then we can use ships with the array / and our damaged enemies sock. Now what do we got here? Ah, yes. Our initial sector, empty sector setup. We have to fix that. We're almost there. Let's give this initial test enemy like 120 health. 20 hit points to start. Just gotta fix that. Silly me. Okay, I need to, yeah, enemy don't damage enemy, and the amount. Okay. Ah, sorry, the type squigglies are showing up here. I was looking down there for some reason. I thought maybe the process in my editor stopped working, but it's still there, so that's good. So this will be energy amount, the input. Right. Okay, so our map function has to, I should do something with that function here. Our map function is getting a tuple. And over its second element, we want to apply this function, which is the enemy, leaving the index unchanged. So I think we can use a handy dandy module called data.function. Use on second. No, that's not right. So what we have here is basically this, where we're going to return this, like that. That's what I was, okay, that's what I wanted. By deflector dot second. Here, not data function, I want a data by functor. Who knew? Thank you, lint. I'll import it like that. Get rid of that. Get rid of this. Second. That is a name shadow binding issue? Really? Oh, I know where it's from. It's from that combat module we don't want anymore. Yeah. We're going to get rid of that, so let's go to data.com, the combat import. Cool. So... Awesome. Okay, so now what we have is, hopefully, if this should all work, I think. We check out our game. Oh, we're getting a runtime error with array. Happens with arrays. What can you do, right? Mirror. Let's fix that quickly. Okay, so this is actually inclusive. There we go. Okay. Right, so if we're far enough away that we're out of range of this ship. Let's see, we're 1, 2, 3, 4, 5, 6. We're just in range to hit that ship. If we do our phaser fire command right now. So if I tell it to fire all phasers with 100 energy, it should hit. Right, we go into fire mode, phaser automatic. We calculate the damage amount. There's one enemy in range. So it's going to divide by 1, which is going to be the whole amount. And it'll damage the enemy, but we don't have any way of displaying that yet, but we'll just have to know that it's there. You can put a debug statement in it just to make sure, but it's there, and we should see our ship energy subtracted by that amount. So 100 times 1. And yeah. So let's do it. Let's fire the phasers. Phasers. 100. Ooh, we missed a step here. Connecting up the command. Oh, command. Yeah. Okay, let's go here. Let's get rid of this unused module. Okay, so saying no command. Oh, right, because we haven't added it to the list of commands to the list of command parsers to try. That's right. Here. Parse fire phasers. Okay, so let's restart the game. That should go now. Still no command. Okay. We can still move 1010. Move 2920 would be an error. Yeah, okay, that still works. If we move to the same spot, but we don't actually go anywhere, we're still using energy. We should probably fix that. Okay, but for our command right now still isn't working there. Okay, so that should work. Yeah, so we try parse command. We still get that, so that works. So run command parser should be there. There's our form where we input our commands. Game C command error. Maybe it's something to do with we input the command palette. Because it should get to here. So this is where we handle the event. We get the key enter press. We get the form state. We run the command parser on the command game state command input that we get from the form state. And we get right. So modify, update the form state, the simulation, we set the command adjust command, no command error, and reset the command input. That should be what we want. Let us add a little debugging here. And right here. show it. Command. But if we get an error, we're getting to this one here. So let's debug.trace as well here. Although, let's see, gamestate command error, render command parse error. Let's render out the input. Something like that. Okay, so that's the command input. These is 100. So it's getting that string and going, but it's going to the error case. Oh, maybe it's because our parser should be making that uppercase. That's probably it. Ha 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 ha. Oh ha ha ha. Dearly me. There we go. Sick. Okay. Glad I got that all sorted out. Oh yeah. That might be something I want to fix for future me. Is make the parser string matching case invariant as well. I totally forgot about that we were upcasing the string before passing it to the parser. Pardon me. Or at least leave myself a little note. Yeah. Leave a little module documentation. I think the syntactor haddock is that. Run command parser. And then it'll look, if I ever want to generate the documentation for it, it'll generate that as a hyperlink to the right function in the module documentation. Okay, so let's take out the debug trace stuff. We compile without warnings. All right, sweet. Okay, so we do phases 100, we run out of energy, boom, we're good. Alright, we can keep going into negative energy, which we shouldn't be allowed to do, but that's fine for now. If we move out of range of the ship, though, say to 1414 at the far corner, we shouldn't be able to, although we are. Why is that happening? Might be our enemy in range calculation is not quite right. So it's still getting into the phaser automatic branch and catching that enemy. Okay. I'll leave that as a note for myself to fix next time. Key. And we have a redundant import. Yeah, let's get rid of that. Okay, let's see if we can clean this up a little bit. We probably should, you know what, we probably should have written some tests for this first. It would have made things a lot faster, you know, it'll make the next phase of things a lot faster. It might have even prevented us from having to go down this route and doing these bug fixing things. However, be that as it may, I think we can do a small cleanup here, pulling all of these out individually. We could just get the ship and use record wildcards to pull out all its fields. Let's put there, game state ship. And then over where we see ship X, we can go ship position X. Let's do ship Y. And ship R. Ship phaser range. Bring this over to the left a little bit. Okay. That's a little better, I guess. I think I have a way of fixing this, but I'm gonna leave that for now. And yeah, let's go make a commit. Have basic automatic phaser fire. We apply damage to enemies in range as evenly as we can, subtracting the damage from the enemy ships and the energy, the total energy used from the player ship. We could probably squash this all down. Store sector enemies in an array so we can index into it and update particular enemies. Add fire phaser command handling. Cool. So, if this is your first time tuning in, thank you for watching. It's been a pleasure and been a lot of fun. All the code for this project and all the projects that I do on the stream usually end up on GitHub. I am Agent Ultra, your fine host, and this has been Lambda Trick. So all the code's up here that we worked on tonight. If you want to fork it, whatever, go ahead, check it out. Eventually, maybe we'll finish this game and make a little release, and you can download it and play it yourself. You can find me, of course, on types.pl in the Mastodon, Fediverse, whatever's, as Agent Ultra there. And, of course, here, if you want to follow and do all that stuff, that would be greatly appreciated. I love it. And if you're watching on the YouTube channel because you're in a whatever reason, different time zone, busy, whatever, you know what to do there. Subscribe, like, all that stuff. Leave a nice comment. Of course, you can follow the link above, too. We do have a Discord server, if you go to that link, where there's a channel for this stream here. You can talk to me about your Haskell projects, ask me any questions that you have about your own projects that you didn't want to ask on stream or whatever, and just generally have a good time. You can also discover cool people who do other functional programming stuff. Things, declarative programming languages, and all kinds of things. So it's a great place to go. Check out that link. Yeah, that's all I got for this week. I usually do these streams once a week on Tuesday evenings at 10 after 8 in the Eastern Standard Time Zone. And hopefully we'll see you next week. Peace out. May all your modems be free, and may your types always check. Take care.